sinusoidal functions. When we look at a sine wave or a cosine wave, what we have here is a series of ups and downs, basically, but we have names for these ups and downs. If you notice here, we've got a distance which is consistent from here at the very bottom up to the highest part. This, by the way, the top part, which repeats over and over at 4 here, in this case, is called a peak. At the bottom, trying to get my K there, the bottom is called the trough. That is the lowest point of the sine wave or cosine wave. Got the R here. My God, this time looking real good here. So there's a peak and trough. Halfway between the highest point and the lowest point, or between the peak and the trough, is the midline. Notice from my peak to my trough is 4, 0 to 4. So the amplitude is considered 2 because it's 2 above here and it goes 2 below here. That is considered the amplitude. Now the second thing we have here I want you to look at is, or say that we got the midline here, we got the amplitude, and the third thing here is the period. The period is any distance from peak to peak or trough to trough, actually from any original point until it comes to that point again. It could be from here to here where it starts in the same position. We usually look at peaks from here to here, or troughs from, from there to there. They'll all be the same distance. And when I look at this looks like it's about 1 point, let's see, that's 1. 1.5 to about 7.5, 6.28. Actually, it's 2 pi, but I put it in numbers instead of pi's here. But yeah, that is 6.28, the period, until it starts repeating again. Now, how do we find the midpoint? There's a simple equation. It's my lowest point plus my highest point added together, divided by 2. In other words, my lowest point here is 3. My highest point is 7. 7 plus 3 is 10. I divide it by 2, and I get 5. And you see there is the midpoint right there. Right? It's not, my mind's not straight. We'll pretend it is, though. So this is the distance when the midline is there to there, and then we can find our amplitude. And, I could manually measure it, or we can use the equation. The amplitude is from the highest to the midline, or actually the lowest to the midline, and it is an absolute value here. My highest equals 7. My midline, we just learned here, is 5. So 7 minus 5 equals 2. Or I could go from my midline is 5, my trough, my lowest point is 3, 5 minus 3 equals 2. It is just the absolute distance between those two. And technically, it would be represented by these 2 vertical lines on each side of that number. And then the period, and I've got it in pies here. I'm going to erase all that. A lot of leading on this paper. Hold on a second. So I've got this in pies here. And what my frequency is going to be where it starts. And let's go right here. This midpoint right there on the midline. And where does it go again? Right there. And that's actually a distance of, it looks like a pi. So there is the frequency is pi. But when I look at it, how many oscillations per 2 pi? Remember, 2 pi goes around a circle here. That's why we're referring to this. So we'd have it start over and go back to its original point twice from 0 to 2 pi. So we either talk about the absolute distance between the original and the thing, or when we're talking about how many times it goes back around the circle ultimately, and that is considered the frequency over 2 pi. Here's another one here, and this one is not right on the center line. So my highest point, let's see, next, now my highest point is 1. My lowest point is -5, so I'm going to add -5 plus 1, and that's -4. Divide by 2, -4 by 2 is -2. Let's see if that looks like it. Yep, there it is right about there. I can pretty much say it's even on both sides. And what's the amplitude? Well, I can go from 1 minus -2. 1 minus -2 is the same as 1 plus 2, plus +2 minus negative positive. And so my amplitude is 3, which makes sense here. I go 1, 2, 3, or I could go from here to the midpoint, 1, 2, 3. Again, the amplitude is not from the highest to lowest, not from peak to trough. It's from the midline to either the peak or the trough. And then my frequency. My frequency is I'm looking at, again, we're looking at how many oscillations for 2 pi. Let me erase this here. And what we got to do is we got to find out, read on the graph, where the pi's are. Well, I can see them right here. Here is 0. Here is 2 pi. Now, what I'm going to say I start here from 0. There's a peak again. There's a second peak, and I'm at pi. There's a third peak. There's a fourth peak. So it's got 4 oscillations per 2 pi. Now, I want to notice some things here. On the left, I have a sine wave. On the right, I have a negative sine wave. Notice they both start out at 0, 0, 0 at the origin. I'm going to explain that in a moment here. The midline's the same. The frequency is the same as well. The only difference is it's actually going backwards around the circle. That's why it's going in a negative direction. In fact, let's talk a couple things about the unit circle here. Why start out at 0? Well, in fact, that's a terrible unit circle, and I apologize for that. But remember, this location is 1, 0, and that's always cosine, comma, sine. So if my sine is 0, that's also 0 pi. And these are pi's across here. And this is, and if it's 0, if it's the sine of 0 pi is 0. Now that, remember, we go in this direction for, it's pi over 4, which is, remember the location that is 0, 1. Pi over 2, excuse me, and this is pi. So pi, if this is 0, 1, let me rewrite that. I'm sorry, 0, 1. That means for my 1 here, I'm sorry, 0, 1 is pi over 2. Here's pi over 2 right here, and then here's the 1 right there. Now, the only thing that's going on differently is with the negative sine wave, we're going backwards. That is the only thing. So this is negative pi over 2. And if we go backwards, we're going to go, here's negative, here's pi over 2, pi over 2, and this is negative 1. And one other way to write this would be, negative pi over 2 is also 0, 0, negative 1. hence the -1 right here. So they both start out at 0. Now, as I said before, the wave, the sinusoidal wave of a sine wave versus a cosine wave looks very similar, except, as I said, the sine wave starts at 0. The cosine wave starts at 1. And remember, this is basically on the xy axis. This is the x, because that's the cosine. This is the y. And over here is the radians across the circle. Why does it start out at 1 here and start out at 0 here? And as I said in the previous slide, we got the unit circle. If this is 0 pi, remember the coordinate is cosine sine. This is 1, 0. So if it's cosine, that's 1 at 0 pi. 1 is my axis here for the x. Here's my 0 pi. It's 0 pi going across here. Here's 1. But if I'm looking at my sine, it's 0 at 0 pi. Now let's look at pi over 2. Pi over 2, which is right here on both of these. Pi over 2 has a coordinate of 0, 1. Well, this is the sine. I mean cosine. Sorry, the first one. So that should be 0 right here, pi over 2. If I look at the sine wave, it would be 1 pi over 2, which is this right here. Here is 1 at pi over 2. So this is why they look so similar, but we're looking opposite. And you can chart the pi over 2, the pi over 4, any part of the unit circle right with the sine wave. Now, what I've got here in this next one is y equals sine x versus y equals 2 sine x. I want you to notice something here. They have the same midline. They have the same frequency. Both have an origin at 0 pi 0. But the 2 in front of the sine x means that there's a higher amplitude. In fact, it's twice as tall. This is 1. This is 1. This one right here is 2. That's what that 2 in front of the sine does. It doubles the amplitude. Now, what if we have after the sine x versus sine 2x? We still have the same midline. We have the same, we do not have the same frequency. We have the same origin at 0 pi 0. But what it does mean is that the frequency takes 2 times as long in sine 2x for 2 pi as it does for one complete frequency, one complete turn, basically one complete oscillation of sine x. We start here all the way 2 pi. It only makes one complete oscillation where we start over. But here, there's 1, there's 2 at 2 pi. So by putting 2 after the sine, or same as the cosine you'll see in a moment, we are doubling the oscillation rate. What if we do the reverse? What if we have the 1/2 in front of it? And this is interesting because it looks the same, but if you look at here, my radial axis here, I got 0 pi to 2 pi, 0 2 pi 4 pi. So it really does is it stretches it out. In fact, I have 1/2 an oscillation per 2 pi. Here's one complete one. I only have half of one right here. So it takes the oscillation takes 4 pi. So that half really puts the oscillations in half as well. We look one more here. Now this is interesting. This is separate from the sine itself. This is sine x versus sine x minus 2. And all I've done here, notice we have the same amplitude frequency. We got an origin here, right here. But look at this. All I've done is by minus 2. Here's my original midline. It's right on the radial axis. By minus 2, I'm dropping it down. Here's my midline now. Let's see if we can calculate the entire wave function based on what we know graphically. I got here, this is 6 at my high point, my peak. My trough is 0. So 6 plus 0 is 6 divided by 2 equals 3. So my midpoint is 3. Right, it's not a straight line, but it's right along here. And there's 3. This is a 3 above it, and this is a 3 below it. So that's going to be my amplitude right there. Because 6 minus 3 is 3, or 3 minus 0 is 3. So now we know, what can we make for this graph? Well, first, we know the midpoint is at 3, and there's that plus 3 right there. I've got my amplitude, which is also at 3. So that puts this 3 in front of this 3. And let's see how many oscillations there are to get to 2 pi. Here is, it's up 3, so this is a sine wave. And here's 2 pi. And it looks like there's 2 complete oscillations. So from 0 to 2 pi, there's 2 complete oscillations. That puts this right there. So this sine wave can be written as 3 sine 2x plus 3. Let's do one more. Let's see what my highest amplitude is. I should say, my peak is 2. My trough, or my lowest amplitude, is minus 2. 2 plus minus 2 is 0. 0 over 2 is 0. So my midpoint is 0, right on the radial axis right here. My midpoint is 0, and my distance is 2 from the midpoint to the peak, or midpoint to the trough. That is going to be an absolute value of 2. And that brings me the amplitude of 2. So really, and how do I know it's a cosine wave? Because it's not starting at the origin. It's starting up here. And if instead of a 1, like the unit circle, like this, it starts out at 2. So that means it's gonna be my 2 is the amplitude in front of the cosine. I know it's cosine because it's not starting at 0. The midpoint 0, so I just put plus 0 here, but I don't have to really put anything. And then let me erase this, and let's see if we can figure out my number of oscillations per pi. Well, let's see. I've got start right here at the origin, and here's 2 pi. It only goes halfway, because the complete one where it starts over basically would be right here. So it only goes halfway. So that is going to be a 1/2, or 2 pi. So it's going to be the amplitude in front, 2 cosine 1/2 x plus 0.